pretty complicated. Um, when you have these events, we have a sample space. There's a chance that we could get a 1 for an outcome. Maybe it's like $1 in a game. We could win $4. We could win $8. We could win $16. They tell us the probability that you get a 1 is 1 out of 32. And then they have kind of a complicated formula for the probability that you get 2 to the k power, right? So each of these are powers of 2. This is 2 to the second, right? If you raise 2 to the second power, then you get 4. This one, 8, is 2 to the third power. So you can see where they're getting k from in this formula, right? This would be 2 to the fourth power, because if you do 2 to the fourth power, you get 16. 2 times 2 times 2 times 2. This is 2 to the fifth, and then obviously that's 2 to the sixth over there. Okay, so they're saying if you want the probability of 2 to the second power, in other words, 2 to the second power, that's calculating the probability of 2 to the fourth, right? Sorry, I said that wrong. That's calculating the probability of 4. Okay, so in this case, k would equal 2. They say to make that calculation, the probability is 1 minus k. It's 2 to the 1 minus k power. So look, for this one, k equals 2. So if you do 1 minus 2, you get negative 1. And so 2 to the negative first power, that's the same thing as 1 over 2. So that's the probability of getting a 4. It's a crazy problem. I mean, it's clever, but it's not. Nobody ever says expected value like this in real life. It never comes up like this. It's nuts. Okay, so basically what we just found out is that the probability of getting a 4, which is another outcome in our sample space, is 1/2. Okay, and I'll show you the next one. Let's say we want to know we know this one. The probability of getting a 1 is 1 out of 32. The probability of getting a 4 is 1 over 2. What's the probability of getting an 8? We're going to use that same formula. The probability of getting an 8. Well, we can rewrite 8 as 2 to the third power. So according to their formula, if you're trying to find the probability of 2 to some k, k is 3 right now. So we could say that's equal to 2 to the 1 minus 3 power. And so if you have 2 to the 1 minus 3 is negative 2, right? 2 to the negative first. Sorry, 2 to the negative second. I can't do math, can I? 1 minus 3 makes negative 2. So 2 to the negative second, that's the same thing as saying 1 over 2 to the second using our rule of exponents. So that makes it as 1/4. Oh, sorry. I'm ahead of myself. This is 1 over 2 to the second. So the probability of getting an 8 is a 1/4. So here, probability of getting a 1, they gave that to us. The probability of getting a 4 is 1/2. The probability of getting an 8, we just found out, is 1/4. And you can keep going like that using that crazy formula. The probability of getting 16 is, that would be 2 to the fourth. So 2 to the fourth, that means k would be 4. So that's 2 to the 1 minus 4. Means we're doing 2 to the negative third, which is 1 over 2 to the third, which is 2 to the third is 2. It's 1/8. And then that pattern is going to keep continuing. If you plug in all that work into the formula like we just did, that's going to be 1/16. You can see that the denominator keeps doubling every time. And then the probability of getting a 64 would be 1 over 32. And we can check this to make sure if we're right, we should be able to add up all these probabilities and it should make 1. And it does if you do that fraction arithmetic out. It's 1/16. It's 4/16. 5/16. Actually, does it? I think I did something wrong here. 1/16 plus it's 3/16, 4/16, that's 1/4. Yep, it does add up. If you add up all those probabilities, it makes 1, which is what we're supposed to have when we add up all the probabilities of sample space. So now that we have each probability, now we can find the expected value. Expected value for 1, 8, 32, or 64, we calculate like we usually do. You take the value and then multiply it by its probability. So the chance of getting a 1 is 1/32. So we multiply the value times the probability. The next value is 8, and the probability of getting an 8 was 1/4. And then the next value was 32, and the probability of getting a 32 was 1/16. And then the next value in the expected value calculation is 64, and the probability of getting a 64 is 1/32. Okay, and so once you calculate that, this is 2, this is 2, and this is 2. It's 2, 4, 6. I get 6 and 1/32, or as a fraction, as one improper fraction, 6 times 32. I don't know, it's huge. 32 times 6 plus 1, that's 193/32.